Welcome back. As you know, I am Eli, the computer guy, and in today's class, I'm going to be showing you how to train your computer with artificial intelligence using a caching mechanism. So if you don't really understand the title for this particular class, don't worry about it, right? And that's one of the hard parts whenever you create classes and you're talking about technology where you create products or you create solutions using multiple different things. Is a lot of times you can come up with a solution, you can come up with a product, but you don't actually really know what the hell to call it. But basically, with the class that we're going to be doing today, is we're going to be teaching our computer system locally using OpenAI. So this is I think the third class we've had in this series where I've been creating a system where I'm able to talk to my computer. So the idea actually is at the end of the day, this whole script will be put onto a robot. So I have a robot that runs around as a computer vision robot. And so I want to put this script onto the robot so that it can not only has vision, but I can actually talk to it and receive responses, right? So we did a class where I just basically showed you how to talk to the computer using Google's speech services. You were able to talk to the Python script. The Python script is literally able to talk to you. So we did that in the first class. The second class, what we did is in order to have more natural speech recognition, we created a list of all of our functions. And then with OpenAI, when I talk to the computer, basically what happens is all of those functions are sent up as a string value along with the query, what we're asking for, and what we request from OpenAI is what function is most appropriate for whatever it is the person is asking for. So instead of simply having hard coding in that when somebody says hello, that the computer says hello back, basically this uses OpenAI, so you don't have to hard code it. So if somebody says hello, it'll get hello back. If somebody says bonjour, they'll get hello back. If they say K or S, they'll get what the current time is, right? It creates a much more natural language functionality. Today with this class is we're going to be adding on a caching component. So we're actually training the local computer based off of the results from OpenAI. So basically what happens is we make the request of OpenAI. I say K or S, I say yo, whatever else. Basically it returns what function I'm supposed to call in order to get the results that I want. What we're going to be doing is we are going to be storing the request and the response into a SQLite database, which is our data store, so that in the future, basically what our script can do is when somebody makes a request, it can look to that database first, see if that request is already stored in the database, that somebody has already asked or made this request before, see what the result is, and then simply grab that result from the local database instead of having to go up to OpenAI. There's a whole number of reasons you would want to create a system like this, and we'll talk about that a little bit later in the class. But just to kind of give you an idea here, when I hit the run button, it says, how can I help you? So today, all of the input is simply going to be in text. I don't want to confuse this thing by putting the speech services in there. If you've been following along, you've already seen how to put speech services in anyway. So how can I help? So basically here I can say, let's say, yo, yo. And then I do yo, and it says query. So the query is yo. Query in database. So it's already in my database. It's already in my data store. SQLite is used. The result, this is what gives me my query set. A result list. So this gives me what the request is and what the response is. And then this is the message that I get back from the function. So basically, if I say hello or any kind of connotation of hello, the computer is supposed to say hello back to me. So I say yo, and it says hello back to me. If I say bonjour, right? Bonjour. Here, query. So this is the query. Query not in database. So it looked whether bonjour was in the local database. It wasn't in the local database, so OpenAI was used. OpenAI's response was hello, so use the hello function. added to the database. Bonjour equals hello, and then the message back is hello, right? So yo was already in the database, so it simply used the local data store in order to provide the results. Bonjour was not in the local database, and so it went out to OpenAI in order to figure out what the hell it is that I'm asking for. And so this is a basic demonstration of the system that we're going to be creating today, so that now we are actually training our local system based off of these OpenAI API results, so that we no longer have to make every single request out to OpenAI, even if we're asking the identical questions. So let me diagram out how this system works so you can get a little bit of an idea of what's actually happening here. So we have an AI-decision-learn.py main script. For this, I'm just going to call it main to make my life easier, right? So this is the main script that we call in order to fire everything off. So this has the OpenAI call in it. It has if-else statements. Basically, this is the main framework for the script that we're going to be running. On top of that, we have another file called AI functions.py. And in this script, we have all the functions that we are going to be using for this system. So we have a get time function that basically asks what time it is from the local operating system and gives that a response. We use a REST API to get what the current weather is wherever we are at, right? We have a get joke function where if you want to ask a joke, it'll go up to OpenAI and it'll ask OpenAI, to create a joke about whatever it is that you want, right? So we have all of those functions sitting within this AI functions.py script here. So the interesting thing that we do with the main, the AI decision, or the AI hyphen decision hyphen learn, the .py, the main script that we have here, is in the beginning, the first thing that we do is we import the AI functions.py script. And so what this allows us to do is it allows us to actually be able to interact with the functions that we've created in this file. So basically we're able to call the functions in this file from this main script. Then what we do on top of that is we read, so we do with open, and basically we open AI functions.py as a file and read that file into a variable value, right? So we also do that. So now everything within this AI functions Python file is now within this variable value in the main script. And so what we do is when we make the OpenAI call, right? So we make an API call to OpenAI. And so what we do is we feed all the functions that are in this file to the API call along with the query. And the query is basically the question that the user is asking. And then we send that to OpenAI. And what we ask is we say, out of all these functions that we're providing you, what is it that the user is asking for? And so that's why I can say yo, bonjour, hola, guten tag, right? All this stuff that I'm not hard coding. Basically, guten tag goes in as the query. There's all of these functions. One of the functions is a hello function. And so OpenAI says Guten Tag most likely means use the hello function. And so that is sent back to the main script. And that's what we've been having going on right now. And basically once it gets sent back to the main script, there's an if-else statement where it says if hello is in response, run the hello function. If goodbye is in the response, run the goodbye function. If time is in the response, run the time function, right? And that's how this system has been working, right? But with this, right, every time I make a request, every time I ask something out of the system, we have to communicate with OpenAI. And there's a whole bunch of issues with that. Again, we'll go into a little bit later in the class. So basically what we've done today is we've decided to use SQLite, right? So there's a database system that I'm really actually starting to like right now called SQLite. It's actually SQLite 3. And what this is this is a relational database that is incredibly easy to use. It is almost as easy to use as just a CSV file, right? Because again, whenever I do these classes, one of the big problems is how do I dumb things down enough so that I can teach you material without swamping you with too much information, right? And the cool part about SQLite is you don't have to create a server. You don't have to do any fancy stuff. You don't have to worry about privileges or any of that kind of thing. It's either installed on your computer by default or you install it with a very simple command to install SQLite. It gets installed, and then basically you're able to call SQLite, and I'll show you this in the Python script really easily and create a database and table really easily. And so what I've decided to do with SQLite is when the main script runs, and basically we make this whole request to OpenAI. Within SQLite, we have a table, and in that table is basically what the query is and what the response is, plus an ID. So what happens now is when the main script goes through and somebody makes a query, whatever their query is, it will now go to the database, see if that query is already in the database. If it's already in the database, it'll take the response. So if I say hola, and hola is already in the database, and hola has already been told that it means hello, it will send hello back to the if-else statement, and we won't go to OpenAI at all. Whereas if I say Guten Tag, it'll take a look for Guten Tag within the SQLite database. It won't see Guten Tag, so there is no response. So then it will go to OpenAI, and it'll say, out of all of these functions, which is most appropriate for Guten Tag? OpenAI will send a response back, and what will happen is our main script will then write Guten Tag and hello into the database, and then we'll also go through the if-else statements so that this script will respond with hello. The next person then to say Guten Tag to this script, it'll go through, it'll look at the query, it'll go to the database, it'll see that Guten Tag is already in the database, we already have a response of hello, and so then it will just fire off the hello function, and we won't even worry about OpenAI. And so this is the very basic system that I've created today. And this is essentially what is called a caching mechanism. So if your computer or your script is going out to somebody else's service, it's getting a response back, one of the things you can do is you can just save the query and you can save the response. And then in the future, instead of going out to their service, you just go to your local database instead, which solves a whole bunch of different problems. So this is the basic idea of what we're doing today. And this is where we start training our own computer. Because once the query is in our database, that's essentially teaching our script, right? The query and the response, so that you don't necessarily need OpenAI going into the future. And again, this is one of those things to be thinking about. Like when we talk about artificial intelligence, when we talk about machine learning, one of my frustrations is that people put this on a really big pedestal, right? Machine learning. Now, don't get me wrong. Don't get me wrong. There's a lot of machine learning that's very complicated that I'm never going to teach you, that I'm never going to learn because it's so complicated. Like there's like Tesla. Tesla's machine learning, I am not going to touch with a 50-foot pole. I just do not care. That is way too complicated, right? But one of the problems people get into is people start thinking about machine learning and they think about Tesla, these really, really, really complex systems. They're like, I could never do that or whatever else. One of the things I want to show you in these classes and doing these projects is things like machine learning can actually be very, very, very simple. So this is a machine learning system where you're teaching your script, your computer, off of these OpenAI responses so that in the future, it no longer needs to go to OpenAI. And so this is one of the things to also be kind of considering whenever you're building things out and realizing, again, fancy stuff like machine learning doesn't necessarily have to be nearly as complicated as a lot of people make it out to be. Now the question is why do you add a system like this to your AI project, right? Is this just simply adding billable hours to your client so you can get a nicer vacation? If you can have your system, whatever your system is, and it can make an API call, it's an API call out to something like OpenAI, and more or less it works all the time. Why add in these additional systems or subsystems? Remember, every piece of functionality you add to a system is also another point of failure, right? The simpler your system is, the more likely something stupid isn't going to happen. So why add SQLite? I mean, it's cool and all. Again, I'm a big fan of SQLite right now, but why add that if that might add additional problems? There's a number of reasons for this. The first is, remember, your system, and again, wherever your system resides, whether your system resides locally, whether your system resides in the cloud or whatever else, it actually has to have a connection to OpenAI. If somebody puts a backhoe through your fiber line, and I always use that as an example because I had to deal with that one time, all of us, your system, sudden, your system doesn't work anymore, right? Somebody says something to your system that's supposed to go to OpenAI, you're supposed to get a response. Somebody put a backhoe through your fiber line. Guess what you're not doing? You're not talking to OpenAI, and so that can be a major problem. So if you have a caching system, at least your system will be able to respond to requests that it's already learned, right? And again, generally with a lot of these systems, we all ask these systems basically the exact same thing all the time. When you think about it, when I go home and I have a home pod and I deal with Siri, what am I asking? I'm asking what the weather is, I'm asking what time it is, and I'm asking to do a timer. Yes, I have a $400 HomePod. I do that and listen to music, right? I don't get Ubers. I don't get Ubers with my HomePod. That's all I do. So, again, if my HomePod was literally learning from me and storing that locally, even when it lost the internet connection, it could still tell me what the time is and maybe it cached what the weather was or something like that, right? So if the backhoe goes to the fiber line, you don't run into a big problem. The other issue that you have to worry about, again, with your internet connection is latency. Da, da. So normally when we think about latency, we actually think about the latency of the packets going back and forth between you and the server. So when you do speed tests, you go to speedtest.net and it tells you what your latency is, and hopefully it's 10 milliseconds, and hopefully it's not 500 milliseconds. That's normally what you're thinking about with latency. But one of the things I'd be thinking about with these types of projects is what you need is you need to make a request. OpenAI needs to process a request, and OpenAI needs to send you a response. Even if this is fast, even this fast. 10 millisecond latency. Eli, I don't have to worry about that. I've got 10 millisecond latency between my servers and OpenAI servers. Yeah, but you got to think about the latency of this entire system. So you make a request. What happens if OpenAI systems are bogged down that day? What happens if OpenAI's engineers screwed up the configurations like they do sometimes? What happens if any number of things occur so that your user says something to your system sends that request up to OpenAI, and 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, you do get the response back, and then, it tells your user whatever the value is for the function, right? That now makes your system seem very slow. And this is one of the big problems we can have in the real technology world is you can build something very well, right? You have NVMe drives, you got a Xeon processor, you got GPUs in this thing, whatever else, right? This is an amazing server. Your server is amazing. Their server, not so much. Remember, the user does not actually care about all the fancy hardware in your server. The user cares whether or not the solution that they're getting, lives up to their expectations. So you can have an amazing piece of hardware here, but if the latency to OpenAI is so long that your user gets frustrated, they're going to call your server a piece of garbage. And I've seen this with vendors. It's funny with vendors sometimes, Because I've purchased products from vendors, and again, they'll be amazing. They'll just be gold plated hardware, the whole nine yards. They just suck. They just suck. And then the salespeople be like, well, our hardware, and they'll go into this thing, and it's like, yeah, well, yeah, but your hardware relies on somebody else's service that is failing for some reason. So I don't care how amazing your hardware is, your product is garbage, right? Each component, you can have one component in your system that's amazing, but if another thing that it relies on doesn't work out well, the users are going to think your product is garbage. And as a salesperson, if you keep pushing the idea that your product is good, even when the user knows that it's garbage, they're going to end up hating you and hating your entire company. Not only are they not going to buy this piece of crap product anymore, they're not going to buy any piece of crap product from you, right? And so that's one of the things to think about. And so one of the nice things with having a SQLite or some kind of caching mechanism here is that the user asks, what's the time? What's the weather? Give me a 20-minute timer. Your system has already heard that 50 times before, so that's stored within the local database, and so they get a response in milliseconds, right? Instead of having to go up to OpenAI and come back, and however long that takes, it goes to the database. The database does just a normal select. Then you get the results back, and it's like, wow, this system is incredibly fast. And that is how a Raspberry Pi system can seem amazing compared to some Xeon server, because again, things about how things are designed. The final thing to be thinking about with things like API calls and why you should be caching things is one of the things I'll tell you about APIs, and this is everybody. I'm not going to beat up an OpenAI for this because this is all these companies. When you make an API request from anybody's API, you don't really know what they're doing with the data. Eli, it's non-login servers. Yeah, let me audit that. Let me go into your infrastructure and verify it's a non-login server, right? One of the things to be thinking about. Right, when your box, your user asks something, that goes up to any API, Twilio, OpenAI, SendGrid, whatever else. You don't really know what information they're collecting to put into their database system, right? Again, when you make a request, they know what your external IP address is. So they know your geolocation data. They know the ISP that you're using. They know a whole bunch of that kind of stuff, right? And so one of the issues that you can run into is that the APIs can basically be storing a whole bunch of information. They can be storing the actual request that you're making that might be valuable to them, but they can also be storing a whole bunch of this metadata type of stuff that could be valuable to them. And one of the questions that you have to ask is, how much do you trust that? Again, right, one of the big things in the technology world, again, we're decision makers, we're real folks doing real work, is sometimes you just have to accept some level of risk. Right? If I want to be able to talk to my computer, then I'm going to be using OpenAI, and so there is an amount of risk there. But the thing is to mitigate the risk. If I can make a request once to OpenAI, get the response back, cache that response, and not have to make the same request again, that is an amount of risk, but it becomes a limited amount of risk to worry about what these API companies, what information that they're grabbing. Again, in this modern world, in Silicon Valley, they fetishize data, right? You've probably heard this. Data is the new oil. One, no, it's not. It just isn't. But just because it isn't, it doesn't mean these people don't think it is, right? And so all these companies are trying to grab your information. Your ISP sells your information. Your mobile phone provider sells your information. Google sells your information. Facebook sells your information. All these companies, somehow people think this is the new oil, and so they just sell a tremendous amount of information, right? So if you create your system, and especially if your API provider knows who you are, right? You know, they know you're the dog dating.com website, right? right? Basically, they know your dogdating.com website and they can start to see that traffic is going up and up and up. Then what do they know? They know more and more people are using your site, and then for any of number of things that can be used for. Investors trying to figure out what's going on with you, competitors trying to figure out what's going on with you, a whole bunch of different things. So, like I say, if you have your local cache, there is an amount of risk with using an API, but you're able to mitigate that amount of risk. And so those are some of the things that to be thinking about with why you would be implementing one of these caching systems. And now, before we get into the script, let me just take a moment to talk about SQLite. So SQLite is absolutely amazing. It's a lightweight relational database system that uses SQL, structured query language. It's installed on many computer systems by default, or if you install Python, and even if it isn't, it's really easy to install onto your system. The nice part about SQLite is basically the value is that the idea is that you use it as a local data store so that it basically has the simplicity of using a text file, so like something like a CSV text file, but you get the power of SQL. So you can do select statements and do all of that kind of thing. And it's really, really, really easy to use. So I have it on this computer, and so what I can do is I can call SQLite 3, so you call it SQLite 3, and then the database that you want to open. So SQLite 3, I want to open AI.db. Now with SQLite, if you haven't used this before, if you don't tell it what database to open, it'll actually open a temporary database, which might be useful for you if you want to deal with information, just basically do some data analysis. What you have to be careful about, though, is if you configure that temporary database with tables and all that kind of stuff, and then you exit, it all goes away. That's one of the things with SQLite is the simplicity is awesome because it's very easy to use, and the simplicity can suck because it's really easy to destroy something, right? Anyways, so if I do this, basically we now see we have the SQLite prompt here, so I'm within the SQLite shell. And from here, I can look for different information. So if I want to see what the tables are, this is slightly different than if you're used to like using MySQL or MariaDB or whatever. If I want to see what tables there are, I can see period tables, and this will show me the tables. Decision. Let me do headers on. And then I'm going to do dot mode column. So I'm going to do this so that when I do a select all statement, it's easier to understand. And then from here, I can do select all from decision, semicolon at the end. Again, this is interesting, no semicolons. When you actually make a SQL statement, you do a semicolon. And basically here we get our result. So this is all of the cached information. So we have an ID, so the number, basically the record number. We have the query, what time is it? And then we have the response we got back from OpenAI of get time. Tell me something funny about cats. Response was get joke. Tell me something funny about cats. Yo, what's the hours? Get time. Is it late? Get time. Time. Right? So all of this stuff basically, right? Is it early? K-Aura S. So all of this stuff now, so basically whenever I make this request, it's going out to OpenAI, we're getting a response, and then we're storing it within the SQLite database, and I'm able to interact with this database using Python. So I'm writing to this database using Python, and I'm reading from this database using Python. And so it becomes a very easy to use data store for caching this type of information. What I will warn you about, if you use SQLite, again, the good part and the bad part, the great part is you don't have to worry about security, right? You're not worried about privileges. You don't have to create user accounts and permissions and all that kind of stuff. What I will warn you, if there's any personally identifiable information in this whole caching system, you can literally copy and paste the entire database somewhere else. So a quote-unquote hacker could copy your database, paste it somewhere else, use SQLite 3 to open the database and see all of the information in there. So it's very easy to use, but it's also very easy to hack. So if you're doing a system like this and you need security, do not use SQLite, use MySQL Postgres, something like that, with security and all that kind of stuff. But basically, this just gives you a bit of an idea of what SQLite is. If you haven't played with SQLite, absolutely awesome. One of my favorite new toys. We are going to be doing a full-fledged class on SQLite a little bit later because we're going to start using it a lot because it's just great for a local data store. But this kind of gives you an idea of what we're dealing with SQLite. So now we get to the actual script. So in this script, we have AI-decision-learn.py, and we have the AI_function.py. If we go into AI_function, this is what contains all of our functions. And so what's nice about this system is it's mostly dynamic. There's a little thing with the if-else statement. You have to manually add stuff in. But basically, I can add any additional functions that I want here, and I don't have to do anything new with the OpenAI query. It will just see these functions, right? So with this, I have a say hello function. So when I'm saying bonjour, guten tag, hola, right? Message is just hello. It returns a hello. Goodbye, same way. I don't understand, same way. Get current time. This actually uses the date time function. So it gets the date time from the operating system, then it returns the date time after we've formatted it. Get current weather. So this uses a number of REST API calls. This makes an API call to find out what my external IP address is. Once I have my external IP address, it makes an REST API call to figure out what my latitude and longitude is based off of that. And then we make an open weather API call to get what the current weather is and return that information. And then down here, we have a get a joke. So we get joke. We send the phrase, whatever the person was asking for there, and then we return whatever the joke is. And so basically all of these functions are here. And so this is the file. All of this is going to be turned into a string that gets sent up to OpenAI when we make the request. And we're also going to be able to call these functions later. We're going to go over here. So here we have import OpenAI because we're going to be using OpenAI. Import AI_function because this is where we're importing that file so that we can use the functions later, right? So see AI function hello, AI function goodbye, AI function don't understand, get time, get weather, get joke. I have to import the file so that I'm able to access those functions from the file later. So we're actually doing that as it's a module. We're going to be importing OS because we have to do a whole bunch of this path crap. And then we're going to import SQLite 3. So it's SQLite 3. We're going to import this so that Python is able to interact with SQLite. Client, OpenAI, .openai. This is where you put your OpenAI API key. I'm not going to show you that. I don't want you folks trying to hack me, but you plug that in there. Then this is where we set up the current directory. So the current directory equals os.path.directory name, os path, absolute path file. So basically, here in our file structure, so we have a ai.db, so this is the database file, in the same folder as the AI decision learn file. And so in order to do that, that's where you have to go through this whole mess where you join and all that kind of thing. One of the pains in the butt with Python. Again, remember, if you don't do this, it will simply store or try to read from the user root directory that you're using. So you use this so you can keep all of your files together. Database name equals ai.db. db path equals path join current directory. With the DB name. Again, you use this so that it joins using the proper syntax for whatever operating system you're using. Then we come down here and we connect to SQLite. So con equals SQLite3.connect with the DB path. So we're going to be connecting in our folder to ai.db. Cursor equals connection cursor. Then we're going to come down here to create table. So this is good for these kinds of basic systems, is you can do a SQL statement that says create table if not exists. So basically, if this table does not exist, create it, right? Makes life easier. So you don't have to manually create it and connect to it later. You can just have your script create it. So table is decision. ID, so you have the ID is an integer. It's a primary key. Query is text, response is text, and close. So this is the create table SQL statement. This cursor that we created up here, we do cursor.execute, that SQL statement, the create SQL statement. So if the table does not exist, it will create the table. If it does, it won't. And then you do the connection.commit. This is a big thing with SQLite. If you don't commit what you did, it didn't actually happen. So make sure you do commit. Then we're going to come down here, file name equals AI function.py, so that's our function script. File path equals os path join current directory, since we already have the current directory with the file name. Then what we're going to do is we're going to open the file path. So we're going to open AI function.py as read as file function equals file function.read. So this comes in as an object, and this is how we turn that object into text by using .read. Then we're going to come down here. So we're going to create a function for the AI request so that we can call this. So we do file function. So file function is that file string, right? So all the functions that are in a string, we're going to send that to this AI request function and what the query is. And then basically here, this is just what an OpenAI query. Role system, you're assisting in choosing the most suitable Python function for a user. Role assistant, you will be provided with available function names for this program. Role assistant, please only provide the name of the function without additional information or responses. Role assistant, do not provide any response other than the correct function name. This is something you have to do with OpenAI. Again, OpenAI is as smart as a human, you know, a 5-year-old human maybe. Then assistant, so we send the file function, so everything within that function file, we're going to send it, and then what the query is. Then down here, we're going to return the response. So the actual text of the response is in response.choices0.message.content. So we're going to assign that to response, and then we are going to return response. We're going to do a while true loop. So a while true loop has this continually loop. So it'll ask you, it'll respond, it'll ask you, it'll respond, it'll ask you, it'll respond, right? So you don't have to just keep, re-hitting the run button. Query equals how can I help, right? That's the whole how can I help thing. Then one of the things that I'm going to do is I'm going to try to clean up that query a little bit, especially since we're storing these values into a database. The cleaner you can make your data, the better it's going to be. Now with this is a very simple cleanup routine. If you're actually putting this into production, you want this to be a little bit more complicated. The first thing that I want to do with the query, so how can I help? Somebody types in what they want. So I want to strip. So the strip method strips the white space from either side. So time with a space at the end is different than time without a space at the end. Space time is different than time space. Right? And this is one of the things that can make your database look like a damn disaster. So we're just going to strip out the white spaces. We're just going to try to make our data a little bit cleaner. We're going to strip out the white spaces. And then also with the query, we're going to use the lower method. And so this is going to change all of our characters to lowercase text. So again, when people are typing things in, if one person types the first letter of a sentence as a capital and the next person does it as a lowercase, those are two different queries. So we don't want to get into that mess. So we're just going to make everything lower. os.system, so we're going to clear the screen. We're then going to print out what the query is. So the query that the person put in with a white space stripped out, everything down to lower. If exit in query, we're going to close the connection. So this is closing the connection for the SQL database, and then we're going to break out of the loop. So we close the database connection, and we leave the program. Down here, what we're going to do is we're going to try. So we're going to do a try statement. SQL_find equals select all from decision where query equals question mark. So this is the safe way of doing this. Instead of simply doing an F string where we put the query value in, you put the question mark, and then you do cursor.execute SQL_find. So the SQL statement, comma, parenthesis, the query. So this corresponds to the question mark. Comma, you do go put that comma in, and then you close everything out. So basically, it's going to run the SQL statement, add in the query value, and this stops things like SQL injection attacks. And then, so this is cursor execute. So result is going to equal cursor.fetch1 of the result, right? So basically we do this select statement and result is going to equal select the latest value that's in there. So again, with this database system, there should only be one value. So hello, there should only be one hello. Should only be one hello. Again, systems are systems. Maybe there's something weird there. So we're just going to fetch one because we only want to deal with that. So basically result is going to be where we fetch one, the first of the results. So there should only be one result and we'll fetch that one. Right? Except, so with this, basically if this SQL statement fails, not that it doesn't find, it fails. It doesn't connect to the database, whatever else, you're going to get this SQL query for find did not work. If nothing comes back, that's not a failure. This is like a connection thing. The SQL statement's wrong, that type of deal. That's where you'll get the except. So if result equals none, so we make this request. So select all from decision where query equals what the query is. We're then going to have result equals fetch the first one of the results. So if result equals none, so basically this means no results come back. What we're going to do is response equals AI request file function query. So what we're going to do is if we don't get any values back from the database, we are going to make a call to the AI request function so that this fires off. And then what we're going to do is we're going to feed it the file function variable value and the query variable value, right? So if none, then what we're going to do is we're going to say SQL equals insert into decision, so the table, query and response. So response is what we get back from OpenAI. So we're going to put in the query of what somebody asked and the response values, question mark, question mark. We do the whole execute thing again, cursor execute SQL. So the SQL statement with the query value and the response value, and then we commit. So if nothing is found in the database, we're going to make a call to OpenAI. We are going to get that response back, and then we're going to store the request and the response in the database for later, and we're going to commit. Then we're just going to do some basic troubleshooting things here. So print query not in database, so OpenAI was used. Print OpenAI response, and this is next line and then tab, so it goes down one line and tabs out what the response is. Print added to database, next line and tab, the query value equals the response value. So that gets printed out on the screen. Else. So basically, if you actually get a value back, so it's not none, response equals result to. So basically with result, when you get result back, it's a set. So it's a query set. So when you get it back, index 0 will be the ID, the record number. Index 1 will be whatever the query was, and index 2 will be whatever the response was, right? So if we take a look at this for the query set, 8 is at index 0, yo is at index 1, and hello is at index 2. So response equals result 2. So basically, when we make the request from the database, so up here, right, result equals cursor fetch 1. So result is now going to be a set. And so response here is going to equal the third index, so 0, 1, 2, the third index in result, which is going to be whatever the answer is. So we're going to print query in database. SQLite was used because it was in the database. Result equals result. So this is what's going to give us our query set, like I showed you before. Print result list, and the result index 1. So we'll say what the query is, and result index 2. What the response was. And then with response here, what we're going to be doing is we're going to be going down and we're going to be looking. So if hello is in response, we're going to fire off the hello function. If goodbye is in the response, we're going to fire off the goodbye function. If understand, we're going to do don't understand. If time, we're going to do get time. If weather is going to get weather. Joke is going to get joke, right? And so the response here is going to be from OpenAI, right? So if it's not in the database, response is going to come from OpenAI, and then we're going to see if these values are in response. If the value is in the SQLite database, response is going to come from result at index 2. And then take a look there, and the function will fire off. And then finally, the message equals the answer. So answer equals AI function get joke. Answer equals AI function get weather, so on and so forth. So with that, if I then hit run, right, how can I help? So I can say yo, right? I say yo, query. So the query that we had all the way up there is yo. If we come down, right, if we look at this, SQL find equals select from decision where query equals yo, execute, and then fetch one. Yo was already in the database, right? So if result equals none, it didn't equal none. There was a result in the database. So we come down here to else, response equals result 2. Print query in database, SQLite use, query in database, SQLite use, print result. So this is the set. You'll notice there's parentheses. So again, when you're dealing with sets in the Python world, you can have lists. So lists have square brackets. You have dictionaries. Dictionaries have squiggly brackets. Sets is a different type of data set, has parentheses. So at index 0 is 8. At index 1 is yo. At index 2 is hello. So response equals 0, 1, 2, hello, right? Then we print out result list. So result list is yo hyphen hyphen hello. That just shows you yo to hello. And then we're going to come down here and then we start looking. So if hello in response, fire off the hello function and we get the hello back. Yeah, let's see here. Yo, girl. Yo, girl. I don't know. Is yo, girl is in the system? There we go. Yo, girl was not in the system. Query, yo, girl. So we're going to come up here. Right? So where are we at? So SQL find select all from decision where query equals yo girl, fetch one, right? If result equals none, yo girl was not in the system. So that we come down here, it'll say query not in database, OpenAI response. It'll say what the OpenAI response was. Added to database, yo girl equals hello. And then since the response, right, since the response is hello, then we come down to the if else statement and we say if hello is in response, then we are going to print hello out here. So that's a basic idea how this system works and how this caching operates with a script like this. So there you go. There's how you can use caching with SQLite to train your own computer system using OpenAI. So this way, whenever you make a request, it looks to see if that request has been made before and what the response was. If it has been made before, you simply resolve everything on your system. If it hasn't been made before, then you go out to OpenAI and you get the results back from OpenAI and you go from there. So basically, this gives you all the power of the OpenAI API and tries to, again, mitigate the risk. If somebody puts a backhoe through your fiber line, then any request that's been made in the past, it will still be able to deal with those requests going in the future because it's been stored locally. Again, if you're worried about the company trying to steal your information, any kind of security issues, you don't have to worry about that so much anymore. Again, things like latency, right? Servers slow down for random reasons, not just your servers, sometimes their servers slow down. If their servers are having bottlenecks, all kinds of weird issues, right, that will affect your users. And so if you have a local database that's stored all these requests previously, even if OpenAI servers literally burned the ground, any request that's already stored in your system will be able to still provide the results regardless of how OpenAI is doing. And so I just kind of wanted to show you this today. Again, trying to open your mind to how you design systems and solutions using artificial intelligence. Too many times nowadays, right? Ever since, ChatGPT, debuted, a bit over a year ago now, everybody just says AI, right? AI will do it. Which again is frustrating as a technology professional. That's the thing what users do. AI will do everything. The important thing that you need to be thinking about is that AI is a very powerful feature, right? It allows you to do a lot of amazing things. But AI is going to be 10% or somewhere around there of your system, right? You need the user interface so that the users can make requests of the AI. You need, again, things like caching mechanisms so that you're not always going out to the AI if you don't need it to. You need the local data stores, again, to store information and that type of thing. There's a whole bunch that goes into AI powered solutions beyond the AI itself. And simply saying AI will do it, is a good way to get laid off at some point, right? Because no, you gotta build all of this stuff out. And this is also, again, when I show you this kind of thing, there's a lot of people out there that are worried that AI is gonna take their jobs. AI is gonna take my job. Right? Again, the important thing to understand in the modern world is when coal miner jobs go away, they deserved it. When node developer jobs go away, well, that's just wrong, right? But the thing to think about, right? I've been doing technology since 1996, right? The MOS program. So when I went into the Army, I started in the Army. The MOS program, when I went into the Army, it was 32 weeks at that time. Literally, the year before, it had been two job specialties. One job specialty had been 29 weeks of training, and the other job specialty had been like 31 weeks of training. 29 weeks and 31 weeks, and they combined two specialties into one and added one additional week of training. I talked with people that got trained after me, and within that MOS line, they basically kept doing that for the next decade of more and more and more stuff kept getting lumped into that single MOS. And basically, as the job changed, as it became easier to repair electronic equipment, as electronic equipment got better, the people started doing more and more things. Again, the way that I think about it is like I got my MCSE and NT 4.0 back in 2000, right? The idea of using MCSE or using NT 4.0 now would just be ridiculous. It would just be painful. It would literally take half an hour to reboot a system, right? It was just brutal, right? Technology moved on, right? We went from the Windows NT world to, again, you start going into the Windows infrastructure that just got amazing. Then you start doing Azure and cloud services, sysadmins, and started to need to know Linux. Again, when I started in IT specifically, you did not need to know Linux. Nobody cared if you knew Linux. It was like, basically, we had people that knew Linux, and it was an oddity. It wasn't actually valuable. Right? You go 10 years in the future, you need to know Linux and you need to know Mac. Now you need to know cloud infrastructure. If you want to be a sysadmin in 2024, it looks very, very different from being a sysadmin in 2000 because things evolve. What's required of a technology professional, what's required of a sysadmin now is just entirely different than what was required before. Again, when we start when we start talking about things like programming, this whole idea that programmers are going to go away, I get a little passive aggressive and snarky because I'm like, hey, jackasses, right? The sysadmin folks have been dealing with this with 2 decades. Oh, surprise, surprise, your jobs may change too. So again, if you're a coder, if you've been a coder for 5 or 6 years, you've been learning how to do stuff, the reality is with AI, with some of this stuff, your job is going to change. Your skill sets are going to need to change. How you think about building and deploying and supporting infrastructure is going to change. Does that mean technology jobs are going to go away? Does it mean technology jobs are going to go away? Or your job is going to go away? right? That's a different thing. So if you're just simply sitting there focused on, I know my little codes, my skill set. I got this skill set 6 years ago, and I think this skill set should, give me a job until I retire. You know, that's what the coal miners thought too. Surprisingly, nobody has a damn bit of sympathy for those folks. Why do you think they're going to have any sympathy for you? And so what you need to be doing is you need to be thinking about how do you add this kind of functionality into the systems that you're creating so that you go on this technology path. Again, I'm gonna be crystal clear here. I'm gonna be brutally, obnoxiously just in your face about this. Technology job, the technology profession is not going to go away. I have been doing technology since 1996, and I can tell you what I do now in the world of technology looks nothing like it did in the 90s, looks nothing like it did in the early 2000s, looks not much like it did in 2010, and it only vaguely looks like what it did in 2015. I'm still a technology professional because I've kept rolling with this technology as things go down the pike. Again, if you get your MCSE and then you learn Linux and then you learn scripting and then you learn Terraform, CloudFront, or whatever else, and then you learn AWS and then you learn Azure and then you learn Python, you're still going to be a technology professional. If you get your MCSE and NT 4.0 and you're like, I'm good, not so much. Not gonna work out for you. So, anyways, that's why I'm trying to teach you all this stuff. Because again, this stuff is really cool. Again, again, using LLMs for that natural language capability, right? So you can now talk to your systems in a way that you couldn't before. Is just an amazing piece of functionality. But again, it is what it is, as I say. It is what it is. So, anyways, as always, I enjoy teaching this class, and I look forward to seeing you at the next one.